Hello everyone, sorry for a little delay. I didn't finish everything in time, as you can tell, but I think this will be a good lesson. There's a lot to tell and a lot that I will teach, many nice things, and this lesson is something that you'll be using for, I would say, 20% of your programming time. You'll be doing what I'll be teaching in this lesson. So it's definitely a really, really important thing to know. What is so important, you might ask? Well, the agenda of this lesson is to talk about how to make data portable, how to make, how to convert objects into something that could be understood by everyone, and at the same time could be easily processed by a machine. So basically we'll be talking about standard data formats. The two most standard ones in XML and JSON. And we'll talk how to serialize and deserialize it using C#. How do you do it cleanly? How do you do it in such a way that you don't mess up your code base too much by just giving it the sole concern of serialization and deserialization? How do you isolate it from the other logic? We'll talk about NuGet. How do you use NuGet packages? We'll start by using NuGet packages, and in fact, we'll be encouraged to use those instead of writing something by ourselves. So basically a way of getting code for free, safe code, popular code, good code that you can just find on the internet. And at the same time, we'll discuss serialization libraries for JSON, serialization, and Automapper as a very good library for mapping, because mapping is what you'll be doing a lot if you plan on working with clean domains separated from serialized data. Indeed, NuGet packages will be downloaded. So let's get to it. First, let's talk about what is XML and what is JSON, why do we need them, and what is the difference. So the problem that we have at hand, that people had at hand back in the days before internet even, is that, well, we did have binary data format which worked fine for machine. Machine could chunk those zeros and ones. However, for a person to make a change in such data would be a pain. They would need to make a change in something that they understand. Then they would need to convert that to a binary, and really nobody would change the data directly. So it was simply not efficient enough. Something that a machine could understand was not something that a human could understand well. And humans wanted something that they could work with as well and make those quick changes by themselves. So when internet came, we have HTTP, we have HTML, and HTML signature syntax is those tags. We have header tags, we have paragraph tags, and many tags. However, HTML is not very strict. We can, let's say, write data, write text outside the tags. So it's almost data, but not really. So we need something specifically suited just for that, for having data in tags. And the answer at the time was XML. XML reminds a lot how HTML looks like. It's very similar, being just a collection of tags. So you can see here we have basically Eureka object, and this object has two properties. It has idea and is good. And XML also supports comments, so we can write comment in XML. XML was the first data format that went widespread when the internet came, when HTML became popular, because it was also quite convenient to send data with through HTTP requests and get data from HTTP responses. So XML was quite convenient. It's like you can see, you take a look at this and you immediately see full picture of what this object is, of what data it has. So the answer for data portability, first answer was XML. Why XML? Well, easy to read and also easy for machine to understand. Stable format doesn't change. And it's very flexible. In fact, XML can be a language of its own. For example, a kind of XML, XSL, you can script how data will be displayed when you open the XML in the web, for example. So here you can see a kind of XML, which basically will render this HTML using a for each loop for a selected catalog. I don't write XSL. Some people still do, and that's actually still decently popular, but I'm not an expert, so I won't go too much in detail about it. But it's there, it can be done. All right. However, JSON is the next thing that is widely spread these days, and that didn't completely replace XML. XML is still popular, but it's the #1 data format for serializing objects. It's very convenient to use, and it's minimalistic. If I would have to summarize, it's minimalistic and easy to use, easier to use. So the new kid called JSON came in town. This is the syntax, as you can see. Basically, you have those curly braces instead of tags, and everything is string based. For numbers, you have numbers without string. For true false, you also have without string, but the rest is string based. So basically, you have three data formats, data types in JSON: true false, numbers. Well, you have integers and floats as well. So 4 data types: integers, floats, strings, and true false. This is basically JSON format. It follows JavaScript notation. The bracket is at the same line as the property name. Dictionaries are a data type, but they are not a data format. And JSON itself is just a dictionary. So this could be understood as a key, and this could be understood as a value. This could be understood as a key, and this could be understood as a value. That's the thing about JSON. In C#, you'll see that it's just a dictionary. JSON essentially is just a dictionary. Key-value pairs. So why do we need JSON? It's minimalistic. It's lightweight, it's fast, easy to read, and it's the most popular right now. Aurora said that there are also like lists or arrays between. Yes, of course there is. That is without saying. It's obvious. So, serialization. We have portable data and we need. So we set our goal is to somehow construct portable data, data which could be moved, transferred, edited in between if needed. And the process of taking an object and converting it into a string, into something that can later on be deconstructed back into that object, is called serialization. So you take an object, you serialize it, you get a string. JSON, XML, doesn't matter much, but the process of taking an object and converting it into some kind of a string for some kind of a data format is called serialization. And the opposite process is called deserialization. So serialization in practice, how do you do it in .NET? For XML, you need three things basically. You need XML serializer, string writer, and XML writer. String writer could be replaced with something else because XML writer has some overloads, but the more common case of how you use it, if you have a string for XML, if you have an object for XML and if you want to just convert it to string, you basically create those three things: XML serializer, string writer, and XML writer. And then you call serialize from serializer, passing XML writer and value, and it will store the string for that XML in string writer. Then you can toString that string writer and it will return serialized object. In this example specifically, you see I also added this line, which basically ignores data for as encoding, because by default it will be UTF-16. Deserializing is a bit more simple. All you have to do is to create XML serializer of that object kind, so a specified serializer for what object it can serialize, and string reader for reading the XML. Again, for writing, you have string writer. For reading, you have string reader. For serialization, you have XML serializer for both. And then again, serializer, what it can do? It can deserialize. So it takes a reader which has the XML and it deserializes into an object. And since it's an object, you still need to convert it into a specific type that you requested. So to some type, basically. The XML in this case can be either, and in this specific case, since it's string reader, it's a string, but it can be either. It will be slightly different for a file, and we'll see how it differs. So, how do you deserialize JSON? Actually, .NET has its own JSON deserializer as well, of course, but that one is pretty much like XML serializer in terms that it's not very beginner friendly. So when you just want to convert a JSON to an object or object to JSON, when you want to serialize to JSON from JSON, you don't want to, like, your first thought should not be that you go and use what .NET has, because there is a very nice package that is super easy to use. And that package is called, well, it's called NewtonSoft.json. But where does the package lie? And it lies behind the gates of all the packages. That is called NuGet. NuGet is basically a place where people create libraries and they share those libraries. And for .NET framework, we share those libraries in a server called NuGet. And there is a public server that you can easily access. You don't need to have any credentials, register anywhere. You just go, it's public, come and get it. You can have private NuGet servers if you want to, but there is a public one always available for you. So you can upload your own packages to NuGet server, and it's all good. Normally, you might ask, how do I trust it? How do I know that the package works? Well, simply because it has, let's say, 1,000,000 downloads, I think a package like that can be trusted. Or even 10,000 plus downloads is something that is a trustworthy package. Is it like .NET GitHub? It's not. It's literally compiled code for you. You install it and it basically adds references and all the dependencies needed for that NuGet package. So it's like compiled code into compiled code, not code itself, not source code itself, but compiled code into a bunch of DLLs or other things. It can be more than DLL. It can be exe or image files or whatever. Yeah. All of those are open source. All that you find in GitHub in NuGet are open source. Actually, I don't know if all are open source. All are free that you find on NuGet. But are all open source? Probably yes. Okay, maybe not. Maybe not. There are a few that I was wondering how it works, and it was paid actually if you wanted to use different features of a NuGet package. Like some NuGets also come in free edition and in paid edition. Yes, I will give the link right after the presentation is done. So in 10 minutes. So yes, NuGet is basically a place where you can get all kinds of code that you want. And before you do anything, the recommendation would be to see if it's done for you. Don't reinvent the wheel and just use what is done for you. And the prime example for that is NuGet and Newton's of JSON. So how do you install a package that we want? You right click on a project, you say manage NuGet packages, and you just type the package that you want, and here you have it. You select a project. Well, if you right click solution, you'll have a bunch of projects. If you right click a project, you'll have a project only window, so you won't have this window. But yes, you select the version of this NuGet package that you want, and there will be all the versions ever since the release, and you click install button, and that's about it. And you see all the relevant information, how many downloads, what's the current version. At the bottom, it also says what are the dependencies. So it's amazing, it's great. NuGet is invaluable in making applications on .NET. So we selected Newtons of JSON, and Newtons of JSON exposes a static class called JSON convert, which you use for serializing objects and deserializing objects. So all I need to do in order to convert an object to a string in C# is to say JSON convert serialize object, and I pass that object. Optionally, I can provide settings or formatting like I did here to make the string not the one line, but to properly indent it so that is human readable. And the opposite is as simple as that. Just say deserialize object and you pass the type to what you want to deserialize, a string. In this case, specifically a string. However, the problem with serialization and deserialization is that all those frameworks, all those libraries require, they usually are based on reflection, and therefore they require a specific structure of an object. So you shouldn't mix your domain with objects that you use for serialization. If you start serializing your domain or from your domain, you'll end up twisting your domain to just conform to the requirements you need for serialization. And if that is the case, your domain objects will be polluted both with nasty attributes. They won't have ever a constructor, or maybe they'll have explicitly an empty constructor just to conform to the requirements of serialization. Basically, you'll have to do workarounds, and in most cases, you won't support multiple types for deserializing. For example, if my JSON serialization is complex, it's very likely that my XML serialization will be complex. And if I want to serialize or deserialize the same type into both formats, that won't be that easy. So you should separate domain and objects that you purely use for serialization. And that kind of an object that you use for serialization or purely for data transfer is called DTO, Data Transfer Object. So here you can see an example of how a data transfer object looks like. I have a class called item. On the left, item has a proper constructor, because what is an item? Every item has to have a name, description, and date of making. And if I don't have date of making, if I don't have any of those three properties, I shouldn't be able to create such an object. Maybe I'll add validation of those properties in a constructor. Maybe I'll have some logic for it as well. However, if I did have this logic while serializing in constructor, it would fail serializing. Because when serializing, I must have an empty constructor. So in this case, for item to successfully serialize, I would also need to add an empty constructor if I want to support this constructor and be able to serialize as well. It's not clean. And therefore, a better solution is to just have a different class altogether dedicated for serialization. So I created a DTO for item, and DTOs actually most likely are called DTO, have a suffix DTO to better clarify the intent. I didn't write that suffix in this case, but just so you know, don't be surprised if you see it. And what's so special about this item? Basically, if I deserialize this item, it will be serialized always into name as JSON property, and it expects non-capital name when deserializing. And when serializing this object, it will ignore description. Like if I have a description and I serialize this object, that node will not exist. Description will not exist. So with attributes that we learned in the last lesson, you can decorate your model properties or model itself and have some nice logic for validation. For serialization. Nice logic for serialization. So here we have logic for serialization, and here we have logic for our business. And if we have multiple versions of models, some that are for our domain, some that are for XML, some that are for JSON, we'll start bumping into the need of mapping. We'll need to map from one model to another, and so on. And you might think that it's really tedious and annoying and is hard, but it's not really that difficult. There are libraries that work with such tedious thing. If it is a problem, if it is a common problem, it's always likely that such problem has already been solved, so you don't need to solve it again. An automapper is a solution for this problem. If I want to map object A to object B, same type, different types, doesn't matter, that's the library to use. So mapper, how do you map? You basically say mapper.map and you specify to what you want to map. And it maps the object for you. How does it work? Basically, if names are matching, it maps. If it doesn't match, it ignores. If you want to map explicitly, you can add mapping configuration, mapping profiles on top. Very easy. And the summary of this, I ran out of time writing a summary, as you can see. The summary would be that when saving object state into a file, don't reinvent the wheel, don't create your own data formats, and use something that is universally common and choose between XML or JSON. Preferably use JSON for saving state, for serializing objects, because that is the format that is most commonly used. That is a simple, lightweight, easy to use and understand format. Practice how to do this, because you will be working with this a lot. And I personally don't have a day without having to look at JSON files. It's that common. All right. Now, please write down a thing that you think you understood very well and a thing that you would like to understand better, or if you have any questions. So please write down those things in detail, if possible, in 1 or 2 sentences. I'll be right back in 2 minutes. Okay, I'm back. Now the slides as promised. Also, I'll link the code. So here are the slides. I didn't push the code yet. I should push it. So give me a moment. Lesson, code examples, save, sync, push. Now let's go to the repository. Let's wait for the push. Here it is. And link to the chat. So here's the link to the repository for all the code examples in the lesson. Basically, out of the box, you have XML serialization, JSON serialization, to file, from file, whatever you want. Okay. Now the things. I think I got XML and JSON quite well, but domain model and DTO went away over my head. Reasonable. It's not an easy thing to grasp. Is there any cons in using binary instead of XML or JSON? Yes. So basically, when you use binary, imagine that you know that in binary you have a serialized order data, and you want to change one item in that order. So what will you have to do? What steps will you have to do in order to modify that data? Well, you will have to convert the binary back to the object, back to something that you could understand. Then you have to modify that object. Then you have to again convert it to binary. However, if it was a JSON or XML, it would be only one step. You directly can modify XML or JSON, unlike binary. So that is the benefit. Binary, however, is way faster, and if you want top performance or minimize the amount of space it takes, you'll probably zip the data or send it as a binary, something like that. Royaloff, I think I understand the serialize and serialize well with the Nugget package, but I have problem to see how the DTO and the class work with the automapper. That is fine. That will be showed in live coding part. Hellhunter asked, Max asked, what does JSON save exactly? And if it saves the data for your project, why would you ignore certain parts like the date of create? Sometimes there are things that simply are not needed. Maybe it's noise. Imagine if you have something more complex, like you have people. You basically save people into JSON, but every person has an attachment to their picture. Literally, a picture that is serialized, that is a bunch of bytes. Why would I want to have bytes? Like something that takes 9/10 of the whole person info space. I don't care about that probably when just reading person info. That's not an essential info. A picture is not an essential info. So therefore, cutting such info out might be beneficial. I don't want to care about the picture, so I exclude it. I ignore it. Catgirl said, from what I understood, it's kind of like single responsibility, that the type shouldn't worry about how it's saved and so on, but rather there should be another class that would be used for storing the state and so on for serialization, deserialization. Yes, that's quite much like it. However, for beginning, for right now, it might look like just single responsibility. However, if you start working with it professionally, you'll end up having problems when you mix stuff. For example, if you try to save something that is both a JSON and then also goes to a database and maybe is even XML at the same time, I don't know how to do that. You'll have a ton of attributes on a single property, a ton of attributes from different domains, and that will just mess you up eventually. And eventually it will be a dead end where you don't have a solution and where you still need a DTO. And don't worry, it's very easy to make DTOs, and I'll show how. There's special tools in Visual Studio for that as well, in live coding part. Royal Gustav said that you should use binary. Well, binary has a use case, but it's not something that you use all the time. And if you look how requests for web look like, HTTP requests, the contents of HTTP request body for SOAP or RESTful services never have binary. They always have either JSON or XML. For RESTful services, you communicate through JSON. For SOAP services, you communicate through XML, most likely. And so Max asked about the picture, and you save the picture somewhere else. Imagine that you're working with UI and UI just displays a list of employees. So you want to deserialize employees into a list, or maybe a requirement is to send over employees, a list of employees, but they don't need the picture. Picture is saved somewhere in a database, for example, but it's not needed elsewhere. So why would I need to deserialize something that I don't need? So therefore I ignore it. I can still work with it somehow if I need to. Maybe I get it afterwards, like you said, it's saved. Yeah, it's just for data transfer. Well, I would say that you use JSON ignore most likely in cases that are either A, when you get that field manually, not via a deserializer, or B, when you mix your domain model stuff with your DTO stuff. So your domain model shouldn't expose everything that DTO does, and so you decorate it with JSON ignore. So I have seen JSON ignore more commonly used as a part of domain model, which it shouldn't be in the first place. So yeah. Right, it's time for live coding. Oh crap. Okay. So for live coding part, I have a bunch of examples made. Examples for both JSON XML. And let's start from JSON. I wrote a static class which basically mimics what JSON, newtons of JSON does, what newtons of JSON convert does. And here you can see it. We have a method to serialize object. So here we take a value. So it takes anything, any object, class, primitive, doesn't matter. We take it. If it's null, we return an empty string because there's nothing to serialize. And if it's not null, we use XML serializer, the same thing that we saw in slides. I want this to be a readable XML. So I say that I want XML writer settings and that I want this to be indented. So properly aligned, basically the same that I would select everything and press Ctrl K D in Visual Studio. And yeah, in the end to string, and if it failed, exception. How does this look like in practice? Let's run the demo. Let's not run this, and let's run this, only this. It was serialization. Okay. So if I run, you can see that from an order like this. So the example that we have is an order, and an order has header and lines. A header is basically a high-level summary of what this order are all about. So header has name, description, to, from, ordered at. And order line is details like amount, price, item. So how many for how much of what items. And yeah. So if I deserialize this, if I serialize this to XML, we see we get this kind of XML. How does this look like in XML itself? It looks like this. Nothing special. All the elements that you saw in the DTO ends up in this string. So quite simple. How is array done in XML? basically you can see it's simply the same tag repeated again. The root element for array is nothing special. There is no indication that this will contain an array. It's understood that from repeated tags. If I repeat it multiple times, XML will understand that this is an array. So you can see high level overview. This is an order. An order has header and lines. A header is made of those things, and lines is basically a collection that contains amount, price, and item. An item itself is name, description, and date of making this item. Pretty simple, readable, understandable, trivial. The thing about XML is that it has namespaces also. I really have worked with this quite a long time ago, so I don't remember the exact syntax, but you have a bunch of namespaces. I think this is like an alias of this namespace. So basically it says that if I want to access this string, I can use XSI. If I want to access this string, I can use XSD. Sometimes you have multiple namespaces for XML. It can go complex. Flexible, but complex in some cases. And how does the opposite look like? How do we actually read from this file? And there was a question, can we read from a file? How does that work? Sure, we can. And that works. So that is serialization. And I made a method, the serialize file. So it takes a path to a file. The same steps, I create serializer for a specific type. And then I say XML reader. I create XML reader, which reads a file. You see input URI, and URI is basically resource locator, unified resource identifier, in other words. It can be even a URL, which contains an XML, or it can be something local to your machine, like your local path. Works either way. So we take that, and it deserializes the path that we passed, and we return the deserialized result as the. How is this different from deserializing object? It's identical, except that here, instead of XML reader, we created a string reader. XML reader expects a file path, and string reader expects a string. What are schemas? Schema is basically a template, a kind of like a class, as in the file which conforms to that schema must follow that template. So it's like a class for creating file formats. For example, for order XML, I could have order XML schema where I define what I expect in order. I haven't really worked with schemas. It's for XML schemas, I haven't really worked. And different files, different types have schemas. There's also database schema, which defines the structure of tables. And an XML schema will define structure of those tags, what tag expects what. So it's like, I would say it's like a class, like a plan of how you build data based on that schema. Literally a scheme, like a plan. Yeah, so that's the difference. That's how you parse how serialize and deserialize XML. So how does that work? Deserialize, let's run. Whoa, okay. So I deserialized this XML in this demo, this one. So the one that we just checked, I deserialized it to XML model specific for this, and it says deserialized path, and we have disorder. Okay, and it prints us basically a summary of this. Basically says testing test, and then it says the two lines, candy, amount, and price. So where does candy come from? Here, candy, and then amount, and then price. And then the same for sofa. Sofa, amount, price. That is the first demo. And let's demonstrate JSON now. Mapping in the end. JSON is absolutely trivial. The only thing that is worth mentioning is how do you deserialize something from a file. Quite trivial as well. You basically I made a method, a static method that literally first reads a file and then deserialize that file contents into some generic type. There probably is more efficient way, but I didn't want to investigate, nor did I care. Okay. So if I run this example, you can see our the same order object being converted now into JSON. So we have a header, we have lines, like Aurora mentioned. How do lines look like? That's the array sign, and the rest is simple. No quotation marks for amount, and the same would apply for Boolean type of variables. And serializing, deserializing, simple. Basically one-liners, and it comes from NuGet. Yeah, Booleans are lowercase. Okay. That is serialization, deserialization. Interesting parts to mention. As I said, I don't want description. So in here, where was it? In serialization demo. In here, you see name and date of making and description, and I ignore item description. So in my write line in my JSON, there should be no description. So as you can see, we have item with just name and date of making, and also name lowercase, because that's the property, that's how we marked it, decorated it. Name should be non-capital, and it was. Also, description should not be included. So you can see the same pattern being repeated, and quite easily as well. All right. Okay. And imagine that your requirements would be this. If I didn't use this, if I didn't use this, I guess it would work in both cases in this case, and I cannot come up with something as complex on the fly. But I can definitely imagine something that would clash. Anyways, it's nice separation of those two things for little effort. Um, okay. Another problem with domain. So what if, let's go back to order. You see here, ideally I want the lines to be not an array, but IEnumerable. Let's make order line IEnumerable. And this is something that annoys me a lot. What happens if I change this to IEnumerable? Let's run. Oh no, it crashed. Why did it crash? Let's read the message. There was an error reflecting type, models order. Cannot serialize member, and it says lines of type IEnumerable. See inner exception for details. Cannot serialize because it is an interface. So here you have it. It cannot be an interface. Yeah, that is a big issue, isn't it? So that is another big drawback of why this works fine when I work with it locally without exposing this to different data formats, and this does not. So here I literally just made something very convenient for me to deserialize, and I still kept the integrity, the same format of my domain model. So a specific model for just serialization, because I can do whatever I want with it. It doesn't impact the other part. I can add attributes here. I can do different string logic, any other logic that is needed just for this serialization. I don't care. It is not being involved anywhere else, and it doesn't matter. So in complete isolation, just for that one point, this is not a central piece of my application. It's just something that goes at the boundary, something that I push or get to at a certain boundary. It doesn't reach my program core. My program core is here in a domain where all the logic should lie for how, let's say, an item is being managed internally by itself. Don't bother if you don't understand what domain is or what is this separation all about. It will be explained in other chapters quite extensively. That's not the point of this lesson. Anyways, the important part, not the important part, but the missing part that I didn't show on the slides was mapping. How does mapping work? Let's go to the mapping demo of both, let's say. And here we see we created an order. So basically all that you saw in the files is the same order that we work with all over again. And we want to basically map domain order into XML order. So something that is for XML into something that is for domain and vice versa. We map from one to other thing. And you might think that it's very difficult, but it's literally just one line of code. It's not really one line of code, and you'll see why not. But let's demonstrate how it works. So before mapping, you can see it was, is this all? Okay, before mapping, you can see it was testing, 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 and after mapping, you can see it again remained the same thing. What is this all about? Basically, I created some order and I printed that order. Then I mapped from that order to XML DTO, and then I mapped it back again to the order. So if I map A to B and then B to A, if mapping works correctly, the result should match the original. So that is this test. Again, the result should match the original. So before mapping, testing, testing, after mapping, testing, testing, before mapping candy amount to price 15.1 matches, and this one matches as well. Our conclusion, mapping works. How did I make this work? How do I create a mapper? Let's look, how do I create a mapper? I say auto mapper configuration setup. This is my class for setting up auto mapper. Basically, when you create a mapper, which is imapper, you create it out of mapper configuration. And you create mapper configuration with a method for configuring it. And basically here it lets me add configuration. It sticks configuration. So I say config, add profile, and I add different mapping profiles for both XML and order profile, for XML and JSON. What do those profiles contain? They contain logic of how do I map from and to JSON? How do I map from and to XML? How does it look like? Quite simple. All of this is automapper things. So a profile is automapper thing, which lets you specify related mappings. So here I created a map that maps from a JSON item into domain item, JSON order into domain order, JSON header into domain header, and JSON order line into domain order line. And the opposite. Without this, it would simply say, hey, the mapping is missing. So if I comment this out and run the example again, oh, it worked. Maybe if I comment this one out. I'm looking at JSON, and this is XML. Yeah, let's go to XML mapping. XML, okay. Let's comment this one out and let's run again. So you can see the good thing about automapper is that errors are actually quite readable. So our first demo was passed and all is good, but then when we started to do mapping, it says before mapping is this, and here it says automapping exception, error mapping types, and it says mapping types. It says it tried to map from XML item, so from this, into domain item, so to this. And so it didn't find such a map. There was no map created for it, and so it threw an exception. So it's quite easy to fix exceptions, errors that automapper throws. You literally just read what it says and do what it asks you to do. So what does it ask me to do? To create a map for those. And I do it. Now, points of interest. If this one has something that doesn't match a name, it will complain. Right, let's go back. Rename to rename it consistently. Okay, let's run again. And again, it will give an exception, but this time different exception. It will say, so I failed because I couldn't map the models. Again, I couldn't map order to order. Because, and it will go, so there was a problem mapping order line in that order. And in fact, there was a problem mapping item. And in fact, there was a problem okay, this one is not so obvious. I wasn't expecting that. From model sort line type configuration. Parameter item. Needs to have a constructor with 0 args or only optional args. Domain item. Maybe by changing that name, I change something else. Change to universe. It's XML item. I think this, yeah, this is XML. So let's call it XML property. I actually don't know. XML item, XML element, yeah. And I think you can give it a name, prefix, name. I haven't worked with it in a while. Let me Google up. Parse XML element. Outside string, probably not. Different name, C#. Different names, element. Okay. Okay. Prefix. Protected internal constructor. That was weird. Oh, not working. Okay. XML element, round, HF, box, choice identifier. Okay. There is a name apparently. XML element name. XML element. Oh, it's a wrong namespace. Okay. Element name. Name. Okay. Run again. Let's see. Auto mapping exception, mapping types. from models order to domain order, from models order to domain order, from domain order, ctor, order line, Xerox on optional works. I think it is because the domain one had this one and it's a bit deceiving. So basically, my point was that in cases like this, you need to map a member explicitly. So you need to say for member, and you follow the convention, the structure. So, sorry, you start from to, so to destination. I map to name, and I then say that how do I map it? So what options are for mapping? Map from, and I say, okay, how do I map to that member? I say from, and this is daunting. So basically I say, okay, from name, from num, I map to name. And for this one, I need to do the same. So num from name. And if I run, it still is problematic. Okay. In that case, I think since we have a constructor, we cannot have mismatching properties for constructor. So I need to do construct using and pass in a function that will create the item. So that's the name, that's the description, and that's the data of making. And I need to do pretty much the same for this one. Okay. This one is for domain. XML. Come on, how many options are there? This one was for XML. Was it not? Oh, right. This one was for domain, and this one was for XML, and XML doesn't take those things. So, right, we put it here. We say that num is this, description is this, and date of making, I know it's misspelled, don't mind me, is this, right? And I don't need this, and I need this. Okay. When you have mismatching models, when names are not matching, it starts getting a bit tricky, and you need to work around those issues, but you can still manage, and eventually it would still end up being worse and convoluted if you did it yourself. And anyways, only a single model needed such tweaking and not the whole thing. So here you can see that it finally maps properly. Yeah. So before mapping, after mapping, matches, all good. Any questions from this? I know that automapper is daunting at first, but it's really easy when you get into it. When we learn about testing, it will be a tool that is quite useful as well. So testing if mapping worked correctly, if the right data is retrieved, saved, and so on. Quite a good tool overall. You can map arrays, different to enumerable list, whatever. You cannot map to enumerable actually, because it needs to know what type it is. You can, however, map from enumerable to a specific type. Roloff, no questions so far. I think maybe if we work with it, but we see when getting there. Okay. Yeah. So if I uncomment JSON and run the full thing, just so that you know it all works, you can see basically those two differences of data. To summarize, here's a JSON, and here is an XML. As you can see, it takes way more space, way more verbose, and unnecessarily so. Dava94 Punk said, it's a bit above my current level, but I'll rewatch the video a couple of times anyways. What matters is to take it easy and not be intimidating of not getting it when just looking at it right now. It's something that you'll get the hang of eventually. All you have to do is to get your hands dirty and work with it. It's impossible to understand this thing. Well, very unlikely that you understand everything just by looking at someone else's code or talking over it. You need to work with it yourself and try it out yourself. But anyways, those libraries that I just showed, I can show you again. Newtonsoft, 350 million downloads. So basically everyone who uses .NET uses Newtonsoft JSON. Next, Automapper, 760 million downloads. Basically, everyone who uses .NET professionally has had their hands dirty with Automapper. A very important thing, very useful tool. It's nice to practice working with it early on because it's very likely that if you get a job, that's the library that you'll be using for mapping. Nobody does mapping by themselves. And no, it is not frustrating. It is natural, normal. Back to the error, if we think about what was the problem was that we had a constructor for item, and item expected a parameter called name, and I changed the thing that I mapped from to num, so it wasn't able to find a property called name, and so it couldn't map num to name because that's not how it works. So you had to construct this object explicitly by yourself because Automapper was not able to. Right. That's all I wanted to show in this lesson, and let's update or removed unused usings. Okay. Push. I mean, learn this subject and make things work, and the challenges learning can be very frustrating for me, in fact. It shouldn't be. It should be fun, especially for you, because you have time to spare and it's supposed to be fun, no pressure on you or no one. You just do it because you enjoy it. That's the essence of it. Now the homework for this lesson, the homework is actually very related to um, lesson 9, to the attributes lesson. Um, so if I go to homework, I already created a branch so you can work on it. I just didn't write proper tests yet. Um, what is the assignment? Basically, you have to go to homework 9 and instead of saving the results, the reports into CSV file, you now need to save them into XML and JSON files. That is the homework. Quite simple one. Just support the 2 additional or just the 2 overall files for saving using those the same commands, the same input. Well, the input now is also not a CSV but a JSON. Any more questions or remarks? David said, I'd say the biggest challenge for me now is that I'm nearing the end of chapter 1, and when I see interfaces or lambda expressions, I tend to freak out. But I'll get there eventually. It just sucks not to be able to learn all that in a single day. It's impossible to learn that in a single day. I started, so I was in university and I started getting the concept of what really interfaces are for only in my 3rd year. So for 2 bloody years, I didn't know what interface was for. I thought it was a contract and I thought it's just a constraint, a limitation, but it's not. So it's not a matter of days and it's not a matter of years as well. It really depends on to what kind of teaching you are exposed to. I was not a good student, but I think I'm not a bad teacher. So, since I know the pain, the struggle, and I know what is difficult and might be misunderstood, I try to emphasize those points when teaching. Also, on Monday, uh, we'll have another meeting. Unfortunately, no responses or results about any projects. So, don't know how will that go, but I'll try to push a bit for feedback for response of the contacts, at least know a answer, yes or no. And in any case, a project will happen and it will be a long-term project. Anyways, uh, based on what I saw so far and my experiment with teamwork for the last homework, I think it will be one big team instead of 2 smaller teams. Simply because, um, simply because I am skeptical about people sticking to the project, and one big team would mean that people can tag replace each other and that there wouldn't be that much pressure on one single person, and it would be basically literally 2 times less pressure. So it's also an interesting experience working in a slightly bigger team. Yep. That's all I have to say for this lesson. So thank you for your attention on Kahoot today. Kahoot will be on Saturday. I ran out of time, like I said again. Um, you're welcome. So see you on Saturday for the next lesson. The next lesson will be an easy one, easier than this one. It will be about attributes. It will be about operators and overloading them. Something that you won't be doing that often, but that's something that can make code cleaner. Um, Thank you all for watching, and see you next time.